All right, so our next lesson in our circles unit, today we'll be using inscribed angles and polygons. All right, so let's start with vocabulary. We got QR codes in your notes, so go ahead and pause the video right now and go ahead and look up these vocab words and write them down. All right, now that we got those vocab words, we all know what an inscribed angle is. And let's talk about how we find the measure of an inscribed angle. An inscribed angle, the measure of an inscribed angle is going to be half of the measure of its intercepted arc. So in this case, we've got measure, we have an ADB right here, and the measure of that angle is going to equal 1/2 of arc AB, which is the intercepted arc. We can also do the converse of that, and we want to talk about the arc. The measure of the arc is going to end up being 2 times the measure of the angle. So we can go both ways with that. If we're given the angle, we can take half of that. We can multiply the angle by 2 to find the arc, or if we're given the arc, we can take half of the arc to find the measure of the angle. So let's try an example of that. So in this circle here, we've got a couple inscribed angles. The measure of angle S is the first thing we want to find. So angle S is going to be this angle right here, and I'm looking for that angle. Now we notice the intercepted arc is going to be from R to T, right there. And we're given the measure RT to be 60 degrees. Now, based on what we just talked about, the measure of the inscribed angle is going to be half of that intercepted arc. The intercepted arc is 60 degrees, so half of 60 is going to be 30 degrees. The measure of angle S is going to be 30 degrees. The second thing we're asked to find is the measure of arc RQ. So RQ is going to be this arc up here, okay? And so to find the measure of that arc, we're going to first need to find the measure of this entire, we know that this whole arc from R to S is going to be 180. And if I can find the measure of QS, I can subtract that from 180, and that'll give me RQ, which is what I've been tasked to find here. So let's start by trying to find the measure of QS. Now again, we're given the angle this time. So the angle, QRS, is given to us as 37 degrees. Now we know that the intercepted arc is going to be 2 times the measure of that angle, so I take 37, multiply by 2, I'll get 74 degrees for the measure of arc QS. But that's not what I'm looking for. I'm looking for the measure of arc RQ. Since RQS, that entire arc up there, is 180 degrees, I subtract 74 from 180 and I get 106 degrees as the measure of arc RQ. All right, the next thing we'll talk about is what happens when I have 2 inscribed angles that intercept the exact same arc. And if this happens, then those angles are going to be congruent to each other. So here's an example of what this might look like. I've got angle HFJ here, intercepting arc HJ. And I've got angle HGJ, also intercepting arc HJ. Well, we know that the angle is going to be half of that arc. So if 2 angles intercept the same arc, then they're each going to be half of the same arc, which would make them congruent to each other. So in example 2, we want to find the measure of angle HGJ and arc HJ. So since, based on this theorem, we can say that these 2 angles are going to be congruent to each other. So the first thing we want to find out is the measure of HGJ. And because those angles are congruent, we know this is going to be 39 degrees. The other thing I'd like us to find out is the measure of arc HJ, and remember the arc is going to be 2 times the measure of the angle. So 2 times 39 is going to be 78 degrees, and that's the measure of arc HJ. Our next theorem says that if a right triangle is inscribed in a circle, then the hypotenuse is a diameter. And the converse of that would be if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle. So in example 3, we have a right triangle inscribed in a circle. The radius of the circle is 5.6 centimeters, and what's the length of the hypotenuse of the right triangle? We don't have a diagram, but we really don't need a diagram. We just need to make connections in this problem with the theorem that's directly above this. So we're given a right triangle inscribed in a circle. Based on the theorem above, if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. So the hypotenuse is going to be a diameter. It gives us the radius to be 5.6 centimeters. We know that a radius is half the diameter, so if we take the 5.6 and multiply it by 2, I'm going to get a diameter that will be 11.2 centimeters. And based on the theorem above, the hypotenuse and the diameter are going to be the exact same segment. So what it's asking for is the hypotenuse of this right triangle, and it's going to be the exact same thing as diameter, or 11.2 centimeters. So we really don't need to draw a diagram for this one. We just need to understand that the diameter of this inscribed right triangle is also going to be the hypotenuse of the right triangle. All right, and our last theorem that we have here has to do with an inscribed quadrilateral. So a quadrilateral that's inscribed in a circle will have opposite angles supplementary to each other. So here we have an example where I have J, K, L, and M all on the circle. So if I connect those, I get my inscribed quadrilateral. And we know that opposite angles are going to be supplementary. And we want to find the value of each variable. So I've got 8x and 4x are opposite angles. And I've got 3y and 3y is opposite angles. And they'll be supplementary, so we'll just go ahead and add them up. So 8x plus 4x will equal 180 degrees. Combine like terms, you get 12x equals 180. Divide both sides by 12. And x is going to equal 15. Same idea to find out what y is. So we have 3y and 3y supplementary, so add up to 180. Combine like terms, you get 6y equals 180. Divide both sides by 6, and y equals 30. Now, one way we could check our answer is to plug all these in and find the measures of all these angles. And we know that all quadrilaterals should add up to 360 degrees. So I plug in x equals 15. I get 120 degrees and 60 degrees for the measures of angles J and L. And if I plug in y equals 30 for K and M, I get 90 for each of those. So go ahead and add them all up. I have 120, 60, 90, and 90. I'm going to get 360 as the sum of all four of those angles. Just a way to check your answer. All right, that's it for the notes. Go ahead and try the try nows. Give them a shot. And as always, if you have questions, make sure you write it down on the side and ask them next time you see them. Have a good day.